erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. None greater than the Sahara Desert, the hottest place on the planet, a deadly wasteland that time forgot. Or so scientists believed, till they unearthed a series of startling clues. The fossils of sea creatures, freshwater shells buried in sand, ancient settlements with human remains. Clear evidence that this stark landscape hides a turbulent past. One that would alter the course of human history and provide a dramatic new chapter in the story of how the Earth was made. Africa's vast Sahara Desert is as big as the United States. The sand alone from this giant expanse could bury the entire world 8 inches deep. It's the largest desert and the hottest place on Earth.
When I first arrived in the Sahara, I was just struck by how utterly barren it was. It's like the color green was removed from the palette when they made this place. Just nothing, grays and browns, and not a scrap of life.
Smith's mission is to unearth evidence of what made the Sahara into the wasteland it is today. Her investigation begins on the desert's far eastern edge, in Egypt. Not in the sands of the Sahara, but in one of the most epic structures ever built by man, the Great Pyramids. The building blocks of this ancient wonder house a remarkable clue to the history of this land, from a time long before the pharaohs even existed.
So, taking a closer look at these blocks making up the pyramids, there's actually these gorgeous marine fossils in here. Most obvious are these flat discs up to about 1 inch wide. They're called nummulites, and they're actually single-celled organisms.
The name nummulites means little coins in Latin. They are some of the largest single-celled creatures to have ever existed. In ancient times, these blocks were cut from quarries across the country and dragged to the pyramid site. Each block weighed 2.5 tons, and it took 2 million of them and over 20 years to build the Great Pyramid. And incredibly, up to 40% of each building block is made up of the bodies of ancient sea creatures like these. What's even more important about the marine nummulites is that they date back 40 million years, and they only lived in water.
It's a piece of evidence that this area, now desert, was once underneath the ocean. You think about the construction of the pyramid, but not necessarily about what it's made of in these gorgeous fossils.
The Sahara now is the world's biggest dust bowl. But the tiny nummulites fossils suggest that it was once very different, that perhaps there could have been water in this barren wilderness. Smith heads further inland to investigate this extraordinary idea. She travels to a remote desert valley near where the pyramid stones were quarried. It's called Wadi al-Hitan. Spread out in the sand lie hundreds of fossils, first excavated in 1983. But these are nothing like the tiny nummulites.
That's a whale. So here's the backbone, the vertebrae. Here's some ribs, shoulder, part of the front fin, and there are the jaws. This guy definitely did not live in a desert.
This incredible fossil is a Dorodon, an ancestor of modern whales, one that died out 36 million years ago.
So based on the size of these vertebrae and how much of the animal was here, it was probably about 21 feet long. This guy tells us that we were underwater. We were in the middle of an ocean.
Wadi al-Hitan is Arabic for Valley of the Whales. This 12-mile dip in the landscape has the highest concentration of fossils in the world. Some were found in the desert floor, others in the cliff walls. The count so far is 400. Almost all are marine animals. Further evidence that the Sahara was once covered by sea.
So here we've got the fossil of a baby whale. You can see the lower jaw down here with some teeth, and the shoulder, the backbone, some ribs, and all curled around. Actually, the tail comes right back to near the head.
As if finding whales in the desert wasn't intriguing enough, there's yet another mystery to be solved. A lot of the fossils are of very young Dorodons, like this one. A delicate mesh of stone helps explain why so many baby whales died in this place.
Wow, so finding that whale fossil told us we were in the ocean. These rocks actually tell us a lot more about what type of ocean we were dealing with. These are all fossilized mangrove roots.
These roots would have been below water. The mangrove trees would have risen above it.
Since trees don't grow out of the deep ocean, we know that this area was actually under shallow ocean at the time these rocks were deposited. Something probably that looked like the Florida Everglades, where there are mangroves growing now.
Smith has discovered the shoreline of the ancient sea. The shallowness of the water could explain why there were so many young animals here.
So one idea, there's a bunch of these baby whale fossils found in this area, and this would have been a shallow protected bay that maybe the whales came just to birth their young. It is absolutely incredible to see a fossilized whale in a place that right now gets less than 1 millimeter of rainfall a year. It's as much convincing evidence for geologic change as I can imagine.
The pieces of the puzzle are coming together to reveal the Sahara's watery past.
So 40 million years ago, this desert would have been covered in the middle of this valley by a shallow bay, probably a brilliant tropical blue-green color. The shoreline would have been off along the horizon, some mangrove trees in the shallowest parts of it.
Inland would have been a vibrant combination of rainforest and swampland. The whales would have been drawn to this ancient shore because of the plentiful supply of food. But their ocean is about to vanish. Marine fossils found in Europe and Africa are evidence that this ocean stretched almost halfway around the world and connected Asia to the Atlantic. It's called the Tethys Sea, and much of the Sahara was submerged under it. The mystery is how and when this lush water world turned into the barren wasteland we see today. The answer lies not in climate patterns, but in geology. The entire African continent is underpinned by a giant piece of the Earth's crust. It's called a tectonic plate, and 40 million years ago, in what is known as the Eocene age, it was on the move.
So at Wadi al-Hitan, we have whales swimming around in this Eocene ocean, all the while the African plate is moving to the north.
Africa collides with Europe, closing the Tethys Sea. But the African plate keeps moving.
So we uplifted the northern part of Africa, and so the Tethys Sea recedes. And we've got this whole area of North Africa now emerged. It's out on land.
The whales of Wadi al-Hitan are cut off and trapped in smaller and smaller pools of water. The deadly Sahara has claimed its first victims. In the quest to discover the history of the vast Sahara Desert, geologists have so far uncovered 2 important clues. Sea fossils in the Great Pyramids of Egypt show these building blocks were once underwater. Whale bones reveal that a sea submerged much of the Sahara 37 million years ago. As the forces of plate tectonics pushed the Sahara out from under the sea, it created a tropical swamp. In order to figure out what made it into the wasteland visible today, scientists have to pinpoint the moment of its birth. But the clues to this mystery turn out to be hidden in the last place anyone expected. 20 million years ago, the Sahara Desert was a lush tropical swamp. Geologists are now piecing together the story of the next 20 million years. Today, the Sahara lies in what is known as the Desert Belt, a region of dry air north of the equator. Here, strong winds clear the sky of clouds and dry out the land below. It stretches through the Gobi Desert in China and across the deserts of the southwestern United States. The Sahara is the largest, and yet geologists know next to nothing about when it was created.
What we have are just these little bits and pieces, these snapshots of what the Sahara was like, because the wind blows away a lot of our record, and what isn't blown away is often covered by sand, so it's kind of hard to find the rocks we need to tell the story we're trying to tell.
One of the few places that shelters a clue to the Sahara's birth is the White Desert. In this hauntingly beautiful site, dramatic shapes have been sculpted out of rock.
Oh, this is great. It's got that mushroom shape.
These structures are called yardangs, and they are a kind of hourglass that could help measure the age of the desert.
This rock is another piece of evidence that this desert was once under the ocean. It's actually a chalk made up of billions of little marine microorganisms. These chalks are actually really easy to erode, sculpted by the wind.
But the wind is a brutal creator. It picks up sand and hurls it at the yardang.
When wind scours or sandblasts the rocks, this is the characteristic shape that we get, this mushroom shape, narrower in the middle. That's because the wind goes faster as you move up from the ground, so it can erode harder, but it has less sand in it since it picks up the sand from the ground. So where we get the most erosion, where the rock is narrowest, is where we have the best mix of fast wind and the most sand.
40 million years ago, the top of the yardangs formed part of the solid sea floor. But the wind picked up once the Sahara turned to desert, and the process of carving out these shapes began. Figuring out how long that took could help pinpoint the age of the desert.
It's hard to say precisely how long it would take for the wind to carve this all out. Something like this, about 15 feet high, soft rock, you're looking at maybe only tens to a few hundreds of thousands of years. But to carve out the whole Oasis Depression, you've got to need at least 1 million years.
But geologists suspect the Sahara is older than 1 million years. In their search for a more accurate date, they next turn to its most iconic feature: sand dunes. Here in the Sahara, sandstorms kick up that can last for 4 days. The sand is hurled across the terrain. Over hundreds of thousands of years, it accumulates into dunes that can tower 50 stories high. Perhaps these mountains of sand hold the secret of the desert's great age.
As soon as the climate becomes arid, you can start building dunes. And if we want to know how long that took, we can try and date the dunes themselves, but that's really hard.
What's hard is that these dunes are constantly shifting. The wind that builds them also blows them away, moving them an average of 50 feet a year. To get a precise age for the desert, scientists need to follow the sand to the end of its journey.
Coarse sand travels slowly and doesn't go.
About the Sahara's past.
What's wonderful about working with the ocean sediments is that they capture everything. They're this very faithful recorder of the sediments that are raining down from the surface.
In 1995, Domenical drilled down into the ocean floor through layers of mud dating back millions of years. Each layer of sediment is like a time capsule. Shallow levels show plenty of this dust blown over from the desert. So Domenical extracted deeper core samples from over 1 million years ago. Still, there was desert dust. Finally, he dug down to a layer that was laid down 3 million years ago, and there, the dust finally stopped. It had taken a voyage to the ocean floor to uncover the turning point from humid tropical landscape into searing desert.
That's a pretty amazing change. You don't think of something as large and expansive and fixed as the Saharan desert as being something capable of such profound changes. And yet this is what the geologic record was telling us.
Domenical had finally solved the riddle of the sands. The Sahara has been a desert wasteland for 3 million years. In the search to discover the age of the Sahara, geologists have unearthed 2 startling clues. Yardangs show that wind-blown sand has been blasting across the desert for at least 1 million years. Deep-sea cores give a more exact date. The Sahara first turned from swamp to sand 3 million years ago. From that moment on, the Sahara became the searing wasteland we see today. It seemed that geology alone could explain the creation of the world's largest desert. Then, a new radar fitted to the space shuttle revealed a striking clue that the desert once harbored a slash of green across its burning sands.
Booster ignition and liftoff.
In 1981, the space shuttle made a surprising discovery. Using a new type of radar, NASA took a 30-mile-wide scan of the Sahara Desert. The radar pierced the sand to a depth of 16 feet and revealed what looked like a hidden network of ancient waterways crisscrossing the desert. This finding stumped scientists. 3 million years ago, the Sahara turned from rainforest into desert. Now it seemed that it had been home to a lot of water at some point in the following 3 million years. Researchers followed the NASA images north into Tunisia, to the edge of a deep depression in the Sahara, the site of their first clue.
This is what we're looking for. Got some quite intact shells here. This deposit is largely composed of intact shells.
And these are not shells from the ocean.
So here we have half of a cadastroderma glaucum shell, which is a clear sign of a freshwater lake. This is just one example of what must be millions of shells. We must be somewhere near the shoreline of the lake here.
Further shell deposits revealed that this lake was giant, about the size of West Virginia. But the shells provide even more remarkable evidence: the date when this lake existed. Carbon dating puts them at 90,000 years old and leads to one conclusion.
To have all these shells here, we must have had a lot of rain falling in the vicinity of this lake and a green Sahara.
Scientists fanned out across the Sahara to investigate other satellite images. They searched for any dips in its landscape that looked like they once held a body of fresh water.
So what was really exciting for me about those radar images that were produced by NASA, we can link this to the GPS, and we're finding evidence of lakes throughout the desert. And some of these lakes are massive.
3 different lake locations were confirmed by the presence of freshwater shells. The series of ancient lakes were so large, they've been dubbed mega lakes.
So this is the far shore of the mega lake. And there was just one of many lakes across the green Sahara.
When Drake added up the evidence of all the lake locations, he uncovered an astonishing fact.
Okay, so if this is North Africa here, and this is the edge of the Sahara Desert, so we're here in Tunisia with a mega lake here, and we know there's another mega lake here in southern Libya, an even larger one here in Chad. If they all meet their maximum size, they would have covered 10% of the Sahara.
That would have made them 3 times larger than the Great Lakes. What is now the biggest desert on Earth was once home to some of the planet's largest bodies of fresh water. Sudden changes in climate have been connected to everything from volcanic activity to meteors hitting the Earth. But climate researcher Peter Domenical had a hunch this wasn't the first time it had happened. He turned to his archive of deep ocean cores.
Our approach was to use deep sea sediments as this continuous tape recorder, if you will, of past climate change in Africa.
By looking at the levels of desert dust in cores dating back hundreds of thousands of years, he discovered the Sahara had changed more than once.
When we first collected these measurements, I really kind of almost fell back in my chair, because what we saw was there are many switches like this in the climate system.
To explain these regular dramatic changes, Domenical looked beyond the Sahara to the rotation of the Earth itself. More specifically, small wobbles in the Earth's orbit around the Sun. The theory is that the wobble causes the Earth to tilt slightly. So the monsoons which drench southern Africa today shift up, pouring rain onto the dunes of the Sahara. Crucially, these wobbles occur every 20,000 years.
So there's this perfect one-to-one match between when Africa was wet and the stage of the wobble cycle. And this goes back millions of years.
Each time the rain belt moves up, the landscape is transformed, and the desert turns green.
To me, the single most impressive thing about the Sahara is how small fluctuations in something as simple as a wobble in the Earth's orbit can lead to these really just totally dramatic changes in the climate of a region that's so large.
Scientists now had evidence of how and why the Sahara turned green. They knew that giant lakes covered much of the desert, but they had no proof they were connected.